A survey of customers to an ice cream parlor resulted in the following table of responses. One of the questions asked was to choose a favorite color from chocolate, strawberry, and vanilla. Various demographic information was asked, as well as including gender. Test at the 5% level of significance for an association between gender and ice cream flavor choice.
First thing we want to do is to set up the null hypothesis. And so the H0 or the H0 will state that there is no association between gender and ice cream preference. The alternate hypothesis will state that there is an association between these two variables. This is a contingency table that we now have to analyze. And we analyze this by calculating a chi-square statistic, where the chi-square calculation is equal to the summation of the observed values minus the expected values squared divided by the expected values. We will have to evaluate this chi-square statistic using the significance level of alpha equal to 0.05. Our first step in this chi-square calculation is to complete the table by calculating all of the totals. The first one we will do is for the female row. So we add up those three numbers, 70, 35, and 60, which will give us 165. So there were 165 women in our survey. And for the men, 30, 32, and 47, which is equal to 109. If we add those two numbers together, we will get 274. So 274 people were in our survey, and you can notice in this particular case it was a random survey, but we did get more women than men. We now want to calculate for the columns, in other words, how many people chose chocolate, strawberry, and vanilla flavors. So we'll add those numbers. 70 to 30 is 100. For strawberry, 67. And for vanilla, it was 107. You'll notice those three numbers also add up, of course, to 274, and that becomes a check on our addition. So now let us start our calculating the expected values for the table if the null, or assuming that the null hypothesis is true. From the table we can see that since the proportion choosing chocolate overall is 100 people divided by 274, or 0.365, or if you prefer, 36.5%. Since we're making the assumption that there is no association between the two variables, then we should expect that 36.5% of the women, the females, will prefer chocolate, and we will calculate that to be 165 times 0.365, or 60.2. For expected values, we need to carry one decimal place would be sufficient in our calculation. And we will write it in the table, and we'll just put it in brackets. So we need now to finish the other 5. For the since we have 60.2 for the women, then to make the total add up to 100, the men will be 39.8. So you can see we do one calculation, and the second one is obtained by subtraction from the total for each column. Let us now move to the strawberry column and do a similar calculation. The proportion overall choosing strawberry will be the 67 total over the grand total 274, which is equal to decimal 245, or 24.5%. As we did earlier, we now can calculate the expected number of females who prefer strawberry, which will be then 165 times decimal 245, which is equal to 40.4. So we've made that calculation. We can write that in the table. And as we did in the first column for the chocolate column, we can calculate for the males by subtraction. And so that number will be 26.6. The other column, which is for vanilla, will now be by subtraction. As the total expected value for the female should be 165. We have two numbers calculated, so the third number will be 64.4. And the final number will be 42.6, again by subtraction. So you'll notice that we had to make two independent calculations, which actually we will see later on is 2 degrees of freedom for this problem. We can calculate the degrees of freedom using the following formula. So degrees of freedom df is equal to the number of rows minus 1, r minus 1, multiplied by the number of columns minus 1. In this particular case, that will be 2 minus 1 multiplied by 3 minus 1, which would gives us a value of 2, which is what we observed when we went through the calculation in the contingency table. We now have to calculate the chi-square value. We have the chi-square formula in place, and so because there are 6 cells in our contingency table, we will have 6 calculations to make. The first calculation will be from the first cell, so the chi-square will be the observed, 70, minus the expected, 60.2. That difference is squared, divided by the expected value, 60.2. That's the first term. Second will be 35 minus 40.4 squared, divided by 40.4. That's term number 2, so we're going to now do 4 more. Using your calculator, you can now calculate these 6 values. So the chi-square will equal, first number when you calculate it should be 1.60. Nope, we're going to report these numbers to 2 decimal places. The second one is 0.72. Third is 0.30. The fourth, 2.41, 1.10, and finally 0.45. And when you add all those 6 numbers up, you will get a chi-square calculation of 6.58. Now that we have the chi-square calculated value, we have to determine the p-value for such a statistic as we do in other hypothesis tests. To do this, we need to go to the chi-square table in your textbook, and we can then draw the actual chi-square curve and show various values based on degrees of freedom. So if you go to your chi-square table, you should be able to find the following values. The usual ones will be 0.05, 0.05, and with the chi-square that does that is 5.991. So what we're going to do now is just list out several of the values from the table. 0.025 will be the next one. And the chi-square that does that is 7.378. And just to complete the picture, we will do 0.1. And that value is 9.210. This is the procedure we will do in all hypothesis tests to determine the p-value. And now we can locate in that particular curve, the chi-square distribution, our calculated value is 6.58. So we can now make a mark. There's where our located. You can see where it is beyond or lower than 0.05, and so we will report a p-value as being between two things. We can't get an exact p-value using our tables, so we can have a region for the p-value, and that will be somewhere between 0.025 and 0.05. Since the p-value that we just calculated is less than our alpha, our significance level alpha of 0.05, we now can reject the null hypothesis and accept the alternate hypothesis. We now have to state our conclusion. Answer the question that we asked at the beginning. We have sufficient evidence to show that there is an association between our two variables, gender and ice cream preference.